Yeah, good morning, Martin. Can you hear me, Martin?
Yeah, I can hear you.
Okay, so we just wait for 4 5 minutes. Let more students join, then we start. Okay.
Very fine, thank you.
Okay.
Yep.
Okay, so yes, good morning, guys. So I just start. Uh, Let me just share my file, then we'll start, right? Just a second. So, what topic we started yesterday? Anybody remembers? Yes, yes. What topic we started yesterday? Yes, so Mana, good morning.
Yes, mom. Good morning.
So, what topic we started in theory yesterday? From where we have to start today? Remember? This we had completed, Abdullahi, processor and memory. This we completed yesterday. After that, I given the introduction of a topic, and then I said we'll complete it tomorrow. Yes, Francis, we are discussing what topic we started yesterday that we have to complete today. Which topic? Do you remember? Yes, Francis. Yes, tell me, Abdullahi. Which notes? Okay, you have sent me the mail. Sorry, maybe I didn't check that. I'll check it today and send it. Okay, today itself. So, okay, if none of you remembers, we started. I said we have discussed all the concepts related to hardware. What are the different input devices, output devices, processors, Okay, and memory devices, also storage devices. Now I said now we have to start with the softwares. Okay, different categories of software, types of software. So that we started yesterday. So now I'm sharing my screen with you, so that we have to complete. So I started with the definition of hardware and software. Okay, so hardware that we can touch, we can see. I think my screen is visible to all of you, right? So uh, I showed you that all parts which are inbuilt in the CPU, that also come under the category of hardware. Okay, so I discussed these parts, whether this is your graphic card, whether this is your buses, hard disk, motherboard, power supply unit. Okay, okay. Now, what is software? Software, what definition I said? I said collection of instruction make one program, and collection of program make one software. Clear? Okay. So now we'll see the types of software. So who has sent me the mail for notes? Anybody has sent me the mail for notes?
Yes, ma'am, I send
Yes,
you.
ma'am, I send you.
Just a second. Who has sent?
Who
Abdullahi.
has sent? Abdullahi.
Sorry, I think
Sorry, I
I
think
got
I got
disconnected.
disconnected.
So yes, I was saying,
Yes, I was saying.
just take one student. I'll send the notes to one student only, and then you can share it among yourselves. So just tell me who will take the responsibility of sharing the notes with others. Whom should I send it? I'll send to one person, and he should take the responsibility of distributing it to other students. So who will take the responsibility? Whom should I send my notes, forward my notes? No one is ready to take the responsibility.
Send to mine. Send to me, madam.
Okay, Martin, I'll send you.
Okay, Martin,
Uh,
I'll send you.
Yeah, because even yesterday I raised the same question.
Right. Right. So you can share
Thank
it.
you.
Yes. Okay.
Thank you.
Now we
Thank you.
come back to mute yourself, guys. So we come back to our topic. This is types of
Okay.
software. So I was saying basic categories of software is application software and system software. Now application softwares are those softwares which no, like you use some apps for games, you use some app for shopping, you for typing you use MS Word, for presentation you use PowerPoint, right? For accounting you have different softwares. For schools they have different softwares, right? So this is basically depends on your requirement. Okay, this can be different for different users, and different users can have different, no, we call it app nowadays. So they can have these apps are basically application softwares. Okay, so they can have it on their system, whichever software is required by the user. If you are in entertainment, if you have music, you want to listen music, you have some publishing job, right? So it depends on your jobs and requirements. So this is not like one thing, it depends on the user's requirement and his jobs. And second thing is, this is not something that without which your system cannot start. Okay, like without Microsoft Office you can, your system will start. Okay, if you don't have the requirement of MS Word or MS PowerPoint, if you don't install it, it will work. That is your application software that you install as per your requirement. Okay, but it's not that your computer will not work without that. Yes, your computer will work without any application software. Okay, now system softwares are those software which are necessary or compulsory for the system to start. Okay, this is not the user's choice whether they want to install it or not. Every system must have these system software. Every computer must have this system software. Why? Because these softwares have the coding how your computer will start. The starting process of the computer is called booting, BOOTING. Okay, so here in system software we have those coding, we have those instruction which system uses for booting. Okay, which instruction system uses while it's booting. Okay, so when system is starting, these instructions are used by the computer. That is why they are called system software, and they are compulsory because your system will start only when you have these system software. Okay, and these instruction which I'm saying are necessary for the computer to start, or we can say for the booting process. These instructions are kept in ROM, that is read only memory. If you remember, we discussed it yesterday that this is a kind of primary memory, but this is non volatile. Okay, because the instructions written in ROM are permanent and they cannot be changed by the user. They are written by the manufacturer because here they write the instructions, that which instructions are required for booting the system. Am I clear? Okay. So example of system software, like I told you the example of so many examples of application software. Now, what are the examples of system software? First of all, operating system. Okay. Operating system is the example of, like, tell me the names of some operating system.
Windows,
Windows and
Ubuntu,
hmm,
Linux.
Unix. Very good. Yes. Yes, Francis, what do you want to say?
Yeah, I had the same answer. Windows XP and Linux.
Right. So what I want to say is, like, whether you have Windows operating system or you have Unix operating system or Linux. So without any operating system, you know that your computer will not start. Even on your mobile, everybody knows that even a mobile has a operating system. Which operating system is used for mobiles?
I think it's Android.
Huh? Sorry?
Android.
Android, right. And which softwares are used for Apple MacBooks and mobiles, iPhones? Okay, study about it and tell me tomorrow. So here I have written these examples: Windows, Unix, and then there was DOS. DOS was the very first operating system, disk operating system. So this was, nowadays we don't use this DOS. Now here we have to understand the relation between hardware, system software, and application software and user. So basically these are the four layers. Okay, so user cannot directly give instruction to the hardware, right? User cannot directly give instruction. Ultimately, whatever work you are doing in computer, you are getting work done by some hardware only. Okay, now if you are giving printing command, you are taking the you are getting the work done by the printer. If you are saying save, that means this will data will be saved in hard disk. That is again a hardware, right? If you say just sort this data, so that means uh, processor is doing the sorting work, arranging the data. Okay, now uh, again processor is your hardware. What is sorting? Don't know what is sorting. In ascending order or to arrange in descending order, that is called sorting. Okay, we'll do today this in MS Word. Practically we'll see, but in maths also you must have done this in first second class. Sorting is taught. Arrange the number in ascending order, arrange the numbers in descending order. That is sorting. So that is done by the processor in the computer. So what I mean to say is that whatever command you give, okay, like you are using camera or you are using speakers, you are using processor, so ultimately user is using the hardware only, but you cannot give command to the hardware directly. Okay, so user uses the application software. Application software, as I'll go to MS Word and there I will click on sort. I will say in ascending order, so I am giving the command through application software. Okay, in music software also, if you go and you say I want to listen to this song, okay, so that means you are using some app. So through some apps only you are giving the commands. How you are giving the commands? You are opening YouTube, that is also an app, right? So you are giving any instruction or any command through some application software. Okay, so user interacts with the application software. Then application software, whatever instruction you are giving to application software, that will forward your instruction to the operating system. Okay, because all the hardware in the computer is under the control of operating system, that is your system software. So if you have to take service of any hardware, first that request will go, your command, your instruction will go to the operating system. Now operating system will decide, it will check whether printer is connected or not, whether your hard disk is free or full. Okay, if you give the command to save and sometimes it says there is no space, or sometimes it says this already exists. Okay, if you give command for printing, sometimes it says printer is not connected. So who checks this, all this, whether input outputs are connected or not? Okay, so all the hardware are under the control of operating system, that is your system software. So whatever command you give in the application software, that will go to the operating system, and then operating system, your system software will check all the hardware. Okay, so this you can say as the monitor of all the resources. So which resource will be provided to which user for how long, okay, whether that is connected or not, whether that is full or free. So whatever is the issue, or if that is available, that will be allocated to you. Okay, so this is uh, from application software. User will interact to the application software. From application software, your instruction will go to the system software, that is your operating system, and then it will again give the command to the hardware. So you directly cannot give command user. We as a user cannot give command to the hardware directly. Rather, the system software will understand your command from the application software. Okay, what you want to do, right? And then it will get that work done by the hardware, whichever hardware you have requested. Okay, maybe you are using USB, maybe all this is hardware, right? So then operating system will be giving command to the hardware, will get the work done by the hardware. So this is how all these layers are connected. Okay, then yes, one example I told you, operating system in system software. Okay, now there are some more examples of system software, right? That no, one is operating system that comes under the category of system software. Next is your utility programs, that also one part of the, that also come under the system software. Okay, now what is utility program? Utility programs are those software which are built to perform some specific task on the system, which have been built to perform some specific purpose in the system. For example, you have antivirus on your system. Okay, those are also software, but they have been built for some specific purpose. Okay, sometimes you have some software on your system for backup. Okay, sometimes you have for, what do you say, compress your files. You have that zip folder, unzip, rar files, right? So these softwares are used for compressing the files only. So there are many softwares like for disk formatting, for backup, for disk recovery. We have different softwares for disk recovery. Okay, for repairing your system problems, cleaning your hard disk, right? So these all are the examples of utility programs. So we have different software for all these purposes. Okay, so this is also come under system software because they are used, they are important for any system to run efficiently. Okay, next, how we can install and uninstall software. So you have to go to start menu, there you have to go to run option. Okay, and then you will put that cd, whichever software you want to install. So then you will look for its setup file, okay, in the cd, and then you will click on that and it will download that setup file on your system. Or, and for uninstalling, you have to go to start, then you have to go to control panel. Okay, there you have this add remove programs option. Okay, and then in this add remove program, it will show you the list of all the software, and whichever software you want to uninstall, you will right click on that, and there you can select that software, click on that software and click on delete. Okay, select that software and click on delete, right? So this is these are the steps for installing and uninstalling the software. Okay, so basically which software we have done, one is application software, one is system software. Okay, Then examples of system software I just said: operating system, utility softwares. There is called device drivers also. You know that, like if I have to install printer, so first I have to install its driver. Have you heard about that? Yes, anyone? Have you heard about this term, drivers, in this system terminology? No. Okay. So sometimes, okay, good, Francis. So which driver you have heard about? You took so long to type yes. Hmm? Tell me which drivers you have heard about.
Uh, so I've ever heard about graphic drivers,
Hmm.
sound drivers,
Very good. Yes.
yeah, and this display drivers and
Ah,
many others.
yes, and you call it card also. Sometimes you call graphic card, sound card. Yes, and for any hardware you use driver term. Like for printers, we have to install its driver first. So driver means that will basically connect through that software, that hardware will interact with the computer processor. Okay, so these are device driver. They also come under system software, and there's third category, that is programming software. Okay, so like for programming also, like if we do the programming, have you heard about any programming language? Anybody has heard any programming language? No. Okay, so you will be doing this in the next semester. So programming. Okay, so the like programming is basically, you know, all these softwares, right? But some programmer has written that software, those apps. Okay, whichever shopping app, music app you use, in fact MS Word, right? Even any operating system, they all softwares have been written by some programmers, some coders. Okay, they write the code for these softwares, right? So for any software which helps in creating or in programming, so the software which helps in programming, okay, those are also one category of softwares, so they which assist a programmer in writing computer programs. Okay, so this is also can be third category of software. So we have done different types of software. Next is, what is language? Now, we are not talking about our language which we speak, we are talking about the languages that are used in computers with reference to computers. Now, reference to computer, there are many programming languages. Okay, now why we need language? Language here is, the meaning of language here is like, I I know English, understand English, right? But how, when I have to give instruction to computer, obviously I'll use English word. I'll say save, I'll say print, I'll say open. Okay, these all are no English words. But computer, does computer understand my English commands? Anyone? If I give any command or any instruction in English, will the computer understand my English commands?
No. No.
Which language it understands?
Which language it understands?
Programming language.
Anybody else? Abdullahi?
Anybody else? Abdullahi?
Yes, Abdullahi. Which language computer will understand? Will it understand my language? When I tell the computer to open, to save, to print. Yes, Zumana. English is our language, users' language. And what is the computer's language?
I think it's
Have
English.
discussed about it. Yes. These all are programming languages, right? But I'm saying all these languages are in English only. Whether I write the program in Python, whether I write the program in HTML, I'll be writing some English like words. Okay. And when I write my program in English, will the computer understand my commands in English? Because when I write program, I write it in English. In all these programming languages, you are right, these all are programming languages. And when I will write these programs, okay, programs means set of instructions. So whichever instructions I will write it in English, right? So now when I will run that program and I have written my program in English, so will the computer execute my instructions? Will it understand what I have written in my program? Can it understand? Which language computer can understand?
Software language.
See, he can understand English
He can
language.
understand
Ours,
English language. Ours,
ours is English language. But computer has its own language, which every computer, whichever instruction you give, whichever programming language you use, okay, computer understand only machine language. That is 0 and 1. I told you about this before also. Machine language, or this is called binary language. Why this is called binary language? Because here only two terms are used, 0 and 1. That is why it is called binary. Okay, and this binary language is called machine language. Okay, and computer can understand only this machine language. Whatever instruction you give, whatever data you give, that will be internally converted into 0 and 1 code. Am I clear?
Yes.
Yes, ma'am.
Right, right. So Zumana, is it clear what
Zumana,
I'm saying?
is it clear what I'm saying?
Yes, ma'am.
Yes, ma'am.
Hmm. Now, so as I said, this is the concept of language. Now, all these programming languages are divided into categories, low level and high level. Okay, so low level is earlier when we started writing programs in older times. That time we, because computer could understand only machine language, 0 and 1, this comes under low level language. Okay, so it can understand whatever you will give, you will write, everything will look like something, the combination of 0 and 1. Okay, now this is very difficult because you have to remember what is the 0 1 combination for A, what is the 0 1 combination for B, what is the 0 1 combination. So every character it has a unique combination, for every number it has a unique combination, for every symbol you have on your keyboard, you know, bracket, star, everything, it has a unique 0 and 1 combination internally. Okay, so whenever we type any character, any number, anything on the keyboard, internally it gets converted into, the computer stores its 0 and 1 combination in its memory. It does not store it as we are typing. Okay, so now when we started programming, so we started writing programs in machine language. We means the programmer. Programmer started writing instructions in computer 0 and 1 language. Obviously, it was very difficult. Like if you have to write add, what will be the 0 1 combination for add? What if you have to write subtraction, what will be the 0 1 combination for subtraction? So for every data, for every instruction, the programmer had to learn all the 0 1 combinations. And this is very difficult. Obviously, this is not easy. And then, on top of that, this machine language is different for every computer, every machine. Okay, so it's not like, okay, fine, if one programmer has written a program in one machine language, okay, for one computer, it cannot be run on another computer because every computer has its own machine language, right? So this was the challenges in machine language, but the advantage was, yes, this is directly understood by the CPU, so no translation is required. Whatever you will write, that is directly understood by the CPU or the computer. But the disadvantage is, obviously, this is very difficult for the programmer to write programs. So the programmer could write very small programs or very simple programs in that time. Programmer could not write complex or difficult programs in the first generation computer. Okay, we did the generation of computers also. Then we improvised it. What we did, we made it a little better. We said, okay, we'll use some machine language and we'll use some English like words so that it will become a little bit easy for the programmer to memorize those English words. Like for add, we will use add. For move, we will use mov, move. Okay, so some English, some words we started using, no, set of symbols and letters. So that is called your assembly language. Okay, where some portion was machine language and some portion was combination of no English like words. So in low level language, two languages come under low level language. One is machine language and one is assembly language. Language is totally 0 and 1, and assembly is, we are using some portion in 0 1 and we are using some portion in English like words. So it bit easier for the becomes easy for the programmer to memorize the code. Now again, if we are using some English like words, how it will be understood by the CPU? Any idea? If we are writing add, add, how computer will understand what is add? Computer is just a machine like a table, chair, almirah. How it will understand what is add? This is a CPU, which is its brain, which translate our commands and tells the hardware what to do and get the work done from the hardware. Now, if I'm writing some portion in English like words, again, it cannot be directly understood by the CPU. Now, what is the solution? Yes. Suppose if I'm I'm talking in English and I'm talking to a Chinese or Japanese citizen. Okay. Now he cannot understand my English and I cannot understand his language. Suppose Chinese language. Okay. Now how we will talk, how we will communicate? Yes. If you don't know my language and I don't know your language, how we will talk to each other? What is the solution?
What is the solution?
Sometimes we use signs.
Hmm?
Sometimes we use signs to reflect what you want.
I'm not getting what you are
I'm
saying.
not getting what you are saying.
I'm saying sometimes we use signs to reflect what you want.
Not sign. What we will do, we need a translator. Okay, there will be a translator in between, which will convert his language in my language. He will explain me in my language, and then what I am saying, he will explain that Chinese person in his, no, he will translate my English into his Chinese. We need a translator for Japanese also if we are talking. You know that. So who understand English also and Japanese also. So he will convert my conversation into his language, translate my language into his language, make him understand, and then whatever he answers or replies, he will convert his instructions into my language. Same way, we need a translator in system also. Okay, what are for assembly? If first we are talking about assembly, so the translator which converts our assembly words into computer machine, that is called assembler. What is it called? Assembler. So when we will write program for assembly language, we need an assembler in between. This is also software, and its job is to convert my assembly language into machine language. Then CPU will perform the operation. It will understand the instruction in machine language. It will convert the data into machine language. Then it will perform the operation, and then whatever answer it gives, that is also in machine language, 0 and 1. We cannot understand if it gives us the output in machine language only. So what it will do, it will again, the assembler will again convert that output of the CPU into my language and show it on the monitor in my language. Okay, so for assembly we need one assembler. So here I have written this translator program is called an assembler. Okay, so in first generation we were having only machine language. In second generation of computer we started using assembly. Okay, now first category is low level. In low level we have two languages come under low level languages, machine language and, yes, which languages come under low level languages? Am I not audible, or you are not listening to me? Which languages come under low level languages? Yes, Francis, go ahead.
I think it's machine languages.
Machine language and,
Machine languages and assembly languages.
yes, no one else is listening. I just discussed two low level languages. One is machine language and second is assembly language. No one is listening to me. These two languages come under the category of low level languages. Are you not getting it, or are you not listening? What is the issue? Please tell me. Is it so difficult that you are not getting it? Then from the third generation computer, we started using high level languages. High level means that now we said the programmer, the user will use only English language, which is very easy for us to remember, easy to for us to understand, to write the instruction. We can write the program of, no, any complicated program, any lengthy program in English. Okay, we cannot memorize 0 1 combination for every character, every instruction. So high level languages are that users will use only English like statements. Those can be your Python, your HTML, your Java, C, C++, any language. Okay, these all come under the category of high level languages. Now we are writing in high level languages. Okay, this is easy for us to remember. Now, how the computer will understand my high level language code? Yes, anyone? I am writing high level languages. Nowadays, everyone writes programs in high level language only. But now, how the computer will understand? Yes, Francis.
It will understand through the assembler program.
That assembler can convert or translate only assembly language. That cannot convert C, C++, Java, Python, CSS, all other languages. Assembler is a translator only for assembly language. So we need another translator for converting our high level language program into machine code. Am I clear? Zomana, are you getting it?
Yes, I'm getting it too.
So we need translators for converting our high level language code, which are written in English, to convert it into machine language so that computer can understand what command I have given. Okay, the CPU can understand. Then these translators are of two types. One is compiler and one is interpreter. Okay, they are of, so one I said, I told you what is high level language, and this is very easy for us to learn and use. Okay, and then what are the two translator? One is compiler and one is interpreter. They both are translator. It's just that some languages use compiler and some languages use interpreter, and some languages use both. Okay, they use compiler and interpreter both. Now what is the difference? The difference is, what the compiler will do, compiler will read your whole program. Okay, and then it will translate it into machine language, right? But in interpreter, it will take one statement one by one. It will pick up one line of code, convert it into machine language. Then it will pick up second line of code, convert it into machine language. It will be executed by the CPU. Then it will come to the third line. If there is no error, it will be translated into machine. CPU will execute it. Okay. So here the translation and execution are carried out for each statement. Okay, whereas in compiler it translates the entire source program. The program we are writing is called the source program into the machine code. If there is no error, it will convert it into the machine code, and then CPU will execute this program. Am I clear till this point?
Yes.
Zomana, Abdullahi, are you getting it, both of you? Yes or no? Okay, so this is the low level and high level language. Okay, then next types of software. One type of software is freeware. What is freeware? Anyone has heard about it? Yes, there is one software called freeware. What is freeware? Freeware is the software which are available on the net free of cost. It is for free. You can download it on your system. Don't have to pay anything. Okay, Sumana?
Yes, ma'am.
Just a second. Just a second. Okay. Yes, so this one type of software is freeware, right? Next is shareware. Shareware is like it gives you to try before you buy, right? So it gives you free day trial for 10 days or 15 days. So it gives you a chance to try that software before buying it. Okay, so when first you can try it for few days free of cost, and then if you want to continue, you have to purchase that software, you have to pay for that software. Am I clear?
Yes, ma'am.
Yes.
Yes.
Okay, this is
Yes,
one
madam.
more category. Then next is firmware. Firmware is what we have done till now, that this is hardware and this is software separately. But sometimes the instructions are not written in language like in programming language. Instructions are embedded on the chip, okay, using these circuits. Like I said, for no ovens, microwaves, fully automatic machine, there is a chip, and that if you have that machine has to perform only one or two operations, so that is not a general purpose machine, so you just make a circuit on that chip and you install it in that machine. So where hardware and software are on one chip only, that is called firmware. Okay, where there is no separate software which will run that hardware. Okay, so there in that hardware only you embed the code on that hardware. Okay, you embed the code, right? So that is called your firmware. This is one category, right? So these are the uh, this is all about software and hardware. Any doubt in this? I'll send you all this file. You can go through it, and as I said, you can read this material from IGNO material. Also, you can download from the internet, and maybe it's available on your LMS also, right? Or you can study anywhere you want. This is not like you have to study from my notes. This I prepare for the presentation purpose. So if you want it, I'll send you, but you can refer your IGNO blogs also material if you have got study material, okay, hard copy or soft copy. So this is uh, this is your wish from where you want to prepare. So any doubt in this, or should I move to the next topic? Yes, tell me, yes or no, should I continue?
Should I continue?
Madam, I have a question.
Yes.
Would you elaborate more about the machine language and assembly where I wanted to confirm the compiler and interpreter from that machine language and assembly, and then you went through the high level and look where we go to the compiler and interpreter. That way, somewhere I wanted to confirm. This is something I wanted
Okay,
to confirm.
okay,
Just go
okay,
through,
okay.
yeah,
Yes,
through, just more like that.
yes. So
Thank you.
machine languages, like whatever instruction I'm giving, machine is taking that instruction directly because I'm giving the instruction in machine language only. So it will execute that instruction. That will be executed by the CPU directly because CPU understand only machine language, 0 and 1 code. But when I'm writing my program in no C language or C++ or Java or Python, then obviously I'm using English like words in this when I'm writing the program. So now how it will understand those English words. So for every language there is, it comes with its compiler. For if I have to run program for, if I have to write program for C, I will install its compiler first. Okay. If I am writing program in Python, my machine should have Python compiler. For Java, I should have its compiler and interpreter. So every language has its own compiler and interpreter. Okay. So as I said, some languages use only compiler, some use compiler plus interpreter. So whatever it uses, first you have to install that. That language comes in a package. So where you will get one editor where you have to write the program. In that package, you will get one compiler which will translate your program, okay, and create its output or exe file. So that every language comes with its compiler. So first you have to install that compiler, then you can write program in that. Am I clear?
Okay. Yeah, now, yeah, this is the last. I'm sorry. Now, you said with the compiler, it takes all the words, but with
Compiler will
interpreter,
translate my English
it all of
into,
them at once.
if I'm using C compiler, that means if I'm writing program in C, the C compiler will be translating my instructions written in C language into machine code. If I'm writing program in Java, I will have one Java compiler, and Java uses compiler and interpreter both. Okay, so there whatever I'm writing, interpreter will be translating that into machine language, and it will be no the pass to the CPU that you have to do this operation. Then CPU will understand its machine code. Okay, interpreter will explain the CPU in machine code. Then it
Okay.
will perform and it will give back the output in machine code, and then this interpreter will again convert that into my language and show it on the system. Because if it directly shows the output given by the CPU, which is which using machine language, I won't be able to understand what the 0101 means. Was because every character, every alphabet, every number has some 01 coding, different unique code which CPU understand. If I am writing A, it has some different code for A. If I am writing B, it has some different code for B. If it give me 0 and 1, I will not understand what is A, what is this A or is this B or C, what. Okay?
It's okay. Thank you, madam.
Okay, now I'll continue to the next topic. Fine? You all got it? Should I move to the next topic now?
Yes. Okay, go to the next.
Okay, let me share my file. Let me see what is the next topic. Now, my next topic is number system. Okay, so in number system, we'll have some idea, no, a little bit idea about what I'm talking about, machine language and all. So that we'll see what are the codes for A, B, C, D, and for all numbers, right? How it's get converted. So I'm starting with that, and we'll continue this topic tomorrow also because this is a lengthy topic. Okay, so just let me share my file. Right, is it visible?
Yes, mom.
Okay, right.
Yes,
So first
madam.
of all, yeah, yeah. First of all, I'm telling you what is number system. So first of all, these number system can be divided into categories. One is positional number system and one is non-positional number system. Now, what is non-positional number system? Non-positional is where it has a fixed symbol for a number. It does not change with its position, like in Roman numbers. Okay, we'll write 1 like this only, we'll write 2 like in this manner only, 3 in this manner only. Okay, if I have to write 65, I know 6 is written like this and 5 is written like this. Okay, so I will write 6 and then 5. If I have to write 665, so I will write 6, 6, 5 in Roman numbers. Okay, it does not matter whether the 6 is only tens position or 6 is on the hundredth position. Okay, the symbol for 6 will remain same, like in Roman number. Even if I am writing 6,650, right? So even then it will be 6650. The symbols are same. On whichever position 6 comes, the way of writing 6 will remain same. About known positional number. Okay, now what is positional number system? Positional number system is where the value of the digits change according to its position in the number. Like what I am saying, suppose if I am writing 100, sorry, 1234. So here the value of 1 is 1000, 2 is 200, value of 3 is 30, and then 4. If I convert this, if I change this, if I write this like 2134, if I write it, if I just change the position of 2134, what it will become? If I write 2134, what it will become? Yes, 2134 will become 2134. Don't you know this? Don't you know this numbering? Yes, tell me whether you know this number system or not. You use this number system or not? Do you have a different number system in your country? Please, anybody replies? Then you don't know that 1000 here, 1 stands for 1200. But if I change it to 134, it will become 2100. So that means if I change the position of digit in the number, its value will change. Is it clear? Yes, am I clear?
Yes, but a question at first.
Hmm?
Kind of clamation, sir, madam.
Yes, Martin, what you are saying?
Now, you're asking a question which they had the answer yes, but in the first place, I not understood that when you change
Okay.
you change, it changes. Now, when you give the last example, like two being the first and one coming the second, it changes
Yes.
to 2000 something.
Okay.
Then now after giving this second iteration, at least I've understood. Thank you. I'm sorry for keeping quiet,
No, no,
but
it's
now
fine.
that
It's
you
good. It's good. I feel good if you. No.
Okay, thank you.
No.
Thank
Communicate
you.
if you reply, if you
Communicate
ask.
if you reply. If you,
I feel good. And
I
this
feel good.
not need
This
to be
not
sorry.
not
So
need
this
to
is
be
what I
sorry.
was saying.
So
TK.
this is what I was saying.
Yeah, TK, yeah.
You just keep yourself muted, otherwise I don't know, my voice echoes from your side, Martin. Maybe you are using two systems, right? That's why my voice echoes. Okay, when you open your mic. So this is what I was saying. If I will write 1, 2, 3, 4, here the 2 is on the hundreds position and 1 is on the thousand position. So the value of 1 is 1200. Okay, but if I just change 2, 1, 3, 4, so the value of 1 is 100 and value of 2 is
And
2000,
value of 2 is 2000,
2100.
2100.
Okay, so this is what is the positional number system. Positional number system that we change, that we uses in our daily life. Okay, what number system we use? This, as I'm telling you, ones position, tens position, hundred position, thousand, 10,000, lakh. So this is the positional number system. Okay, and the number system we uses in our language, in our daily life, is called decimal number system. This is decimal number system. Why this is decimal? Because here every number has a value in increasing order of 10 power. Power of 10 starts from 0. The first digit will be multiplied by the power of 10, 0. Then next will be multiplied by the power of 10, 1. Next power of 10, 2. Next power of 10, 3. As I just explained, 1234. So that means every digit gets multiplied by the power of 10, which starts from 0 from the right hand side. Okay, and from right to left we move, and the power of 10 is increasing by 1. Okay, it will become 10,000, 1 lakh, no, like that. It keeps on increasing. So here the base, the number system that we use in our daily life is decimal number system. Why? Because here we use only 10 digits. What 10 digits we use? 0 to 9. Whatever number you write, right, it will use out of this 10 digits only. Whatever biggest number you want to write, you will use these 10 digits only. That is between 0 and 9. Right? Any number you want to write will be written using this 10 digits from 0 to 9. So that is why it is called decimal number system, because it uses 10 digits. Okay. Next, but I just said the computer uses binary number system. We uses decimal number system. Right? Binary is where base is 2. And which digits are there? 0 and 1. Digits used are 0 and 1. Okay, so this is binary number system. Decimal is base is 10 and digits used are 0 to 9. Then we have two more number system which are used in the computer: octal number system and hexadecimal number system. What is octal number system? Where the base is 8 and the digits used are 0 to 7. This becomes 8. This makes 8. 0 to 7 are 8 digits, right? And in hexadecimal, base is 16. Now, for 16, we have maximum 0 to 9 numbers. Whichever number you write, you will use any digit between 0 to 9, right? And these 0 to 9 are only 10 digits. Okay, 0 to 9 are 10 digits. But the base is 16 here, so we need 16 digits, right? We have 10 digits. So for the next 6, we don't have any number except 0 to 9, right? So for the next 6 digits, we use A to F. For 10, we will write A. For 11, we will write B. For 12, we will write C, like that. Because in computers, it starts counting from 0. So what is 16 for us? It will take it 0 to 15. And we have 0 to 9. So for rest 10 to 15, we will use A to F. Is it clear? Yes, these
To
number
me,
system.
to, to me, no. Let's go back again. Once, when thank you. With binary, I got something, but octa, no. And hexa, no.
In binary, base 2 digits used are 0 and 1.
Yes.
Octal base is 8, digits used are 0 to 7. 0 to 7 makes 8 digits.
Hmm.
For hexa, base is 16. But in mathematics, we have only 10 digits, 0 to 9. Do we have any other number except between 0 to 9? No. We have 10 digits only. 0 to 9 makes 10. And for 16 base, you need 0 to 15. Its counting start from 0. So that means from 0 to 15. Okay. So what we will use? For 10, we use A. For 12, for 11, we use B. Okay. I must have written it somewhere. Just like this. Okay. So for 10, 0 to 9 we have 10 for no 10 numbers, then A will be used. 0 to 9 we have, then for 10 we will use A, for 11 B, 12 C, D, then 14, then 15. So here 0 to 15 will make 16 digits, out of which we have 0 to 9 numbers, and 10 to 15 we use A, B, C, D, A to F for 10, 11, 12, 13, 14, 15. Am I clear till this point? Should I continue?
Excuse me, madam.
Okay. Now we have studied all
Excuse me.
these number systems. What are these number systems? What are the base of that number system, and what digits are used in that number system? Now the question is, like, if I am typing any number, I'll be giving in decimal, but computer will understand in binary. Okay, so it needs to be converted in binary, and whatever computer is giving the output in binary, that needs to be converted in my number system, decimal number system. Okay, so now we will see how all these numbers are converted from one binary to decimal, decimal to binary, binary to octal. All these conversion we will see. Okay, how all these numbers are converted from one number system to another. First we will see how to convert a binary number into decimal. Okay, so we know that binary number will be given something like in 1010 something. Okay, now you have to convert it into decimal. So what you will do, you will take, you will pick up one number from the right hand side. Okay, and keep multiplying it with the power of 2 starting from 0. First number will be multiplied with the 2 raised to power 0, next 2 raised to power 1, next 2 raised to power 2, because this is binary number. As I saw, like in decimal, what we do, we multiply each digit by the power of 10. 10 raised to power 0, 10 raised to power 1, 10 raised to power 2, like that. Okay, so if it is binary, so that means here each digit will be multiplied by the power of 2. Okay, 2 raised to power 0, then 1, then 2. So you will keep increasing the power by 1. Then you will solve it. If there is 0, so obviously whatever is the power 0 multiplied will give you 0. And rest, whatever you will get after adding, that is your decimal conversion. So because this is decimal number, so in the base I will write 10. If in the base, if I'm whatever, like here, in the base I'm writing 2. So it depicts that this is a binary number. If I'm writing 10 in the base, it depicts that this is a, what is this? If I'm writing 10 in the base, What number is this? 21. Which number system is this? I'm just asking which number system this 21 is written. If in the base 10 is written, which number system is this? That means 10 is the base of which number system? I think I should not ask you anything. I should just keep on speaking like this only. If I'm writing 2 as the base, that means this is the binary number system. If I'm writing 10 in the base, that means this is the decimal number system. So this is how we convert this binary number to decimal number. Okay. Next is how we will convert the octal number into decimal. That means I have to take one number from the right hand side and multiply it, because this is an octal number. So I will multiply it with the power of 8, and the power start from 0. Okay, from right to left, the power will keep on increasing. Just a second. Sorry, guys. Yes. So, yes, I just repeat. If I have to convert from binary to decimal, okay, so you have to multiply from the right hand side. You have to multiply each digit with the power of 2, starting from 0, right? And if you have to convert octal to decimal, then you have to multiply each number with the power of 8, because this is an octal number. Again, from the right hand side, power starts from 0. Is it clear? Yes.
Yeah, so
I'll
clear now.
yes. And same way, if you have to convert from hexa to, what do you say, hexa to decimal, then what you have to do, you, from the right hand side, you will pick up one number, you will multiply it with the power of 16, because this is hexanet number. Now what you have to do, one more step here. Here you will write FDE, then you will write E stands for 14, D stands for 30, F stands for 50. You have to convert it into its numeric value, then you multiply it, add them, and then it will give you its decimal number. Okay?
Okay,
Now,
okay, okay, okay.
now next I'm telling you the vice versa. Today, if time allows, we'll do some practice. Otherwise, I'll share these files with you. You can, no, this will, you will understand it when you will do it yourself, when you will do it manually. Okay, here I'm telling you the steps. You solve these problems, then only you will have practice. When you practice it, then only you will have command and you will understand this. Okay, I have one practical file also for your practice, where all the numerics are given. So I'll send you that file also, so that you can practice it. Now I'm telling you the vice versa. If I have to convert from decimal to binary, then what I have to do? Now see the steps. Okay, now what I have to do? This is decimal number is given and converted into binary. From binary to decimal, I was multiplying it, okay, with the power of 2. But here, from decimal to binary, if I have to convert, that means 25 is given, which is decimal number, and I have to convert it into 0101. Okay, so how I will convert it into binary? I will divide it by 2, right? And then I'll be writing the remainders in one column. I will say 2 1 the 2, 2 to the 4, 24. Remainder is 1. Then I will say 2 6 the 12. Remainder is 0. 2 6 the 12 is fully divided. Remainder is 0. 2 3 the 6. Remainder is, what will be the remainder?
Zero. Zero.
0. Then I will
Yes.
divide it. 2 1 the 2. 2 1 the 2. Remainder is
One.
1. 2
Because
1 the
one
2.
very,
Remainder is 2 1
one
the 2.
is
Remainder is, very good. 2 0 the 0.
yes.
Obviously 1 is, less than 2, right? So I will say 2 0 the 0, and remainder is 1. 1. So you have to divide it till you get 0 here. Okay. Now what you have to do? You have to write these remainders in the reverse order from bottom to top. 1 1 0 0 1. This is the binary conversion of this 25. So when this is decimal, so in the base 10 is written, and this is binary, so in the base 2 is written. So from the base you will come to know whether this is binary or whether this is decimal. Okay. Same way, if I have to convert decimal to octal, then what I have to do? I will divide it by 8. I will say 8 3 the 24, remainder is 1. Obviously 3 is less than 8, so it will, I cannot write 8 1 the 8, I will say 8 0 the 0, and remainder is 3. And now write these remainders from bottom to top. So 3 1 is the answer, is the uh, octal conversion of this decimal number 25. Like I have given 23, you have to convert it into this 23 in decimal is given, and you have to convert it into hexa. So you will divide it by 16. 16 1 the 16, remainder is 7. 16 0 the 0, remainder is 1. Then write this 1 7 in reverse order. This is the hexa conversion of this decimal number. So this is how we convert from decimal to binary and from binary to decimal. Okay. Tomorrow we'll do how to convert the fractional number, decimal numbers. Okay. But first I want you to practice this till this point. Okay. So I'm sharing one file with you, and you practice these numbers now and show me the answer. Just a second. Can you do it? Should I give you some questions for your practice? Or you will show me tomorrow?
Give us, and we try.
Yes, I'm asking you want to try it now? Should I give you some numericals?
Madam, give us now, and we try.
Yes,
And we
okay.
give it
Write down
now.
the questions.
Okay.
1011.
Yes.
Convert this from binary to decimal. I'm writing
From
this
binary. From binary to decimal.
decimal.
Okay.
You know how to do it, or should I show you the file again?
You can show us for the last.
Yes, just a second.
Thank you.
Yes, this is here one example I am showing. Now I have given you another number. As per this rule, convert that binary number into decimal number and tell me what number you get. You can see one example on the screen. Tell me what is the answer. Send the answer in the chat box, Francis. What is the answer?
Okay, let me share it.
Tell me what number you got.
I've got 12.
No, that is wrong. Do the calculation again. There must be some calculation mistake. Yes, Zomana, this is 11, right? This is correct. Martin and Francis, do it fast. What taking you so long? Such a basic numbers I have given, small numbers. Okay, you. This is the answer. You should get this 11, and I'll share this file with you today, and then you can practice this by tomorrow. Okay, tomorrow we will continue this topic. After 15 minutes, we'll meet again for the lab session. Be ready with MS Word on your system. Right? Okay. So we'll continue MS Word. Yes, you want to ask something, Martin? Unmute yourself. You are muted. You're muted. Muted.
Yeah, obviously. Thank you. I'm saying,
Yes.
yes. If we come back for the second session, I would ask you that to first give much time on this small kind of thing, the binary part of it, because I think it is more important at this time if we can understand it at this early stage than ahead of us
You
tomorrow.
want to continue this theory topic, number
Yes,
system.
yes,
Number system.
yeah,
No, no,
yes. I
no.
think it will
Martin,
help
no, no,
us.
no. Martin, no. This I cannot take in next lab session.
Okay.
Okay. I'll continue this
Okay.
topic tomorrow. Tomorrow again in the theory session. I'll continue this.
Okay, then thank you.
Okay. I'll come back with this chapter and I'll send you the notes and you can practice it by then. So you'll be more clear by tomorrow on this topic. If you will practice this numericals from my notes. Okay. So see
I'm
you
waiting
after
for.
15 minutes.
Mm.
Be ready with your systems. MS Word. Okay. Thank you. Bye.